My name is Jan Piotrowski. I'm a VP at Brave, where I help run our search business. And today I'll be talking to you about, admittedly, not the sexiest of topics, but one that if you work in AI, which I presume most of you do, or you wouldn't be here, affects your role at least indirectly, and that's data. And for those of you waking up now and realizing that you're going to talk about data and weren't planning to be, I won't be offended if you leave, but for those of you willing to stick it out and listen to me for the next 15-ish minutes or so, I think we can all agree data is extremely important. And that's particularly true in AI, since the starting point of any machine learning approach is training data. And the large language models that we've been hearing about today, that we've been reading about over the last 9 months and excitedly playing with, they're for the most part all trained on raw text. And for that text to be useful for the models, it needs to span a wide range of topics, genres, languages, right? And a good place to find text that fits all that criteria is, of course, the web. It's worth noting that the web is absolutely massive, as we all know. If we try to guesstimate and just take the Google search index as a lower bound for the size of the web, the Google search index, Google has said, is hundreds of billions of pages long, or has hundreds of billions of pages, and it's at least 100 petabytes in size. And this was years ago. And for context, 100 petabytes is like 100 million gigabytes, right? So extremely large. The actual web is likely larger than the Google search index, and then you have the deep web on top of that. And that's not even accounting for all of the private data sets that reside in large enterprises, which is even larger than what's publicly available. I read somewhere that Walmart alone generates 2.5 petabytes of data every single hour, which is astounding. So it should come as no surprise to anyone here that right now, every day, we are generating more data than we ever have before. Right, and so these are some of the things we're doing on a daily basis. 333 billion emails sent, 24 billion texts, a lot of streaming, 150 million hours of meetings on Zoom, which sometimes it might feel like every day is like that for us. And more importantly, a lot of swipes on Tinder. And with something so dauntingly large, a common entry point for a lot of LLMs is the Common Crawl data set. Not sure if you've heard of it, but Common Crawl is a nonprofit. What they do is they crawl the web and they provide free public snapshots of the web. The last snapshot was in October of last year, almost a year ago, and it was 80 terabytes large. Very, very large. And Common Crawl it's a standard source. It's cited in a lot of kind of the big name projects we've heard about, used in Google T5, GPT-3 had Common Crawl, Gopher as well, and many, many others. It makes sense, though, to look at the data underlying Common Crawl with a critical eye. So a lot of researchers have combed through the data and said, the data is very large, and it's very broad, but there are certain inherent biases in the data. For one, there's an overrepresentation of younger users from developed countries. Also, Reddit and Wikipedia, two large components of the data, tend to skew very male and very young. And these are just some of, there are countless other issues and questions around censorship of what makes its way onto the web, obscene materials, duplicate materials, materials that might not represent, certain ethnicities, certain religions, certain cohorts of people, right? So there are all sorts of issues that you kind of need to consider when you look at a training data set. But that recognition that the underlying data is important has led to a lot of interesting projects that have really tried to take humongous data sets like Common Crawl and make more manageable, more accessible, high quality curated data sets. So these are some of them. I won't go into all of them, but you may or may not have heard of web text or open web text, which was the publicly available version of it. C4, the GPT-3 training set was really interesting. There was a bunch of different things. The pile, which focuses mainly on like academic resources, and then a bunch of search engine APIs. All of these are an attempt at filtering the open-ended web. So they take something like Common Crawl and do something interesting to make it more manageable. Web text is a really interesting one I like to talk about. What they did is, I think OpenAI worked on web text initially, and they took this huge corpus of Common Crawl and said, this thing is 380 terabytes, extremely large. So they took out Wikipedia and said, that has its own benchmarks, and they focused on Reddit. And they said, we're gonna scrape all outbound links from Reddit as long as they have 3 karma or 3 upvotes, which is really fascinating because you're taking a rating system that's native to Reddit and using that as a quality threshold for your training set. And effectively, they took something that was 380 terabytes large, Common Crawl, and reduced it to a more manageable 40 gigabytes. What we've learned through these projects and others is that, one, there's a massive amount of data out there, both public and private. And two, it's really challenging for nearly everybody to train on quote unquote all of it. There's just too much. So you're gonna have compute limitations, you're gonna have resource limitations. And even if you are able to train on such large data sets, there are always biases and inherent flaws in the data that you should just be aware of in any case. And so the goal, of course, is to always look for high quality data that's curated, manageable, and perhaps fits your specific needs. For the back half of this presentation, I'm gonna introduce you to what we're doing at Brave, and specifically with Brave Search, and hopefully convince some of you that we at Brave Search are providing data that's worth your consideration for your data training needs. Brave's been around for about 7 years, 8 years. Some of you may know us for our flagship product, which is the Brave browser. It's a privacy protecting browser. It's got about 60 million users, monthly active users. Browsers and search engines tend to go hand in hand. In fact, a lot of people think that they're the same thing. And so we've always had ambitions to do things in search. And about 2 years ago, just over 2 years ago now, we launched Brave Search. And Brave Search is an independent, private, and AI-driven search engine. For those of you familiar with Brave and Brave Browser, the privacy piece probably isn't that surprising to you. We're very big on user privacy. But the word independent here might throw people off. It might be a little confusing. So just to dwell on that, independent here doesn't mean that we're a standalone company or some sort of entity status, which we are a standalone company. But independence in the context of search engines means that we don't rely on any other search engine for our search results. The dirty secret in search engine land is that nearly every Western search engine relies on either Google or Bing results and just slaps their logo on it. And it makes sense because it's extremely expensive to start a search engine. It's extremely expensive to run a search engine. It's really time intensive. And let's face it, there are search engines that have been around for 20 years. And so you're always playing catch up. You're always going to be playing catch up because Google, for example, has been building a search engine for 20 years. So they have a very, very huge index. And so it makes sense that any new search engine would prefer the API route and use the APIs of Google or Bing. But if you think you're using DuckDuckGo, you're actually just seeing Bing results. If you think you're using Yahoo, it's mostly just Bing results, which is a path we didn't necessarily want to take. And so we have our own independent index, and we show our own search results, and more importantly, we have our own data. Brave Search is probably the largest, I'll say Western, because there are a lot of search engines in China. There are a few in Russia that probably wouldn't fall in here. But Brave Search is the largest Western search engine at scale besides Google and Bing, the two elephants in the room. We've indexed over 17 billion pages over the last 8 years. We add about 50 to 70 million pages every day. Some of that is new content that's never been seen before on the web, and other times it's just refreshed content of existing pages. Our search engine supports 30 languages, and we're a fraction of the size of Google, but every single site in our index has been visited by a real search user. And that's an important distinction because there is an extremely long tail of just terrible sites that are like gibberish or duplicates or obscene or whatever. They have no business being in any sort of search index. And so we like to think of ourselves kind of like the projects I was mentioning earlier, the curated, filtered data sets. We consider ourselves encompassing the 99% of the web that people actually want to visit or that actually matters. We are big fans and adopters of AI. We were experimenting with AI long before the ChatGPT craze happened, where suddenly every search engine had to have AI. We have a feature in Brave Search called the Summarizer. It's pretty self-explanatory with the name, but given a user prompt, it returns a text answer. It pops up about 15% of the time. But most importantly, it includes citations. So you see the little citations on the bottom for where that answer came from. And citations are important because it gives the user confidence that this isn't an AI hallucination and that the answer is actually rooted in some real result, right? The neat thing about Summarizer is that we built Summarizer on a much, much smaller model than any of the big names out there. And the reason why it was able to work is because our Summarizer is hooked up to basically a fire hose of our Brave search data. And that's probably the most important point I can share here today, is that search engines are absolutely helpful, sometimes even critical for any AI application. There is a reason why ChatGPT partnered with Bing. There's a reason why Bard heavily leverages Google search. And that reason is that search engines are probably the best tool for filtering out garbage from your LLMs. For one, an obvious thing is that search engines return real-time results, right? So it's very frustrating when you're talking to a chatbot and the answer is, I'm sorry, our data only goes up to X and Y date, right? You want real-time results. You want to know about who won the Oscars this year, not 3 years ago. So real-time results are important. A second, more nuanced reason is that search engines are often used to refine user prompts. So many AI applications don't just take the user prompt and throw it into an LLM. What they're usually doing is taking the user prompt, running it through a search engine to refine that prompt with relevant search results, and then running it through an LLM. And so the user, this prevents a lot of hallucinations that might happen. And again, there's a confidence level where you know where some of these answers are coming from. We're an open source company at Brave. We very much believe in transparency. We don't believe in walled gardens. When we launched Brave Search about 2 years ago, we publicly stated at the time that we would release a search API to power other search experiences, which we did a few months ago in May. So that's been very exciting for us. It's dismaying for us as we look around and we see peers in the space trying to restrict access to APIs or similarly raising prices on APIs to basically unsustainable levels for most people to use, because we believe in user choice, and the cool AI applications that you all in the room are building, those should be encouraged and available to everyone, not necessarily squashed by incumbents who don't want them to be seen. So we have a very open philosophy, and we apply that to our search API. I kind of wanted to end this presentation with an example of what our API looks like. It's a very simplified example, and I did it prior to this weekend, the slides. And so I guess I was betting on a little more of a positive outcome for the Women's World Cup. I'm really sorry if this evokes any harrowing memories, but unfortunate. But here, you see what any kind of AI, a typical AI application, what that UX might look like. You're asking the user for a prompt, and in this scenario, they're curious about the Women's World Cup. You would take that prompt, send it to Brave Search through a simple API call. You don't really need to know the text except the highlighted part, which is sending a parameter related to the Women's World Cup. Of course, there are other parameters that you might want to send around language, etc. But for a simple example here, we're sending a query about the World Cup. And our API will return up to 20 web results related to that query. And there's a lot of information here. I tried to abbreviate it. I also tried to highlight some of the important stuff, but then I later realized I completely failed because there are things on there that I wanted to highlight and I didn't. So please bear with me. But when you send an API call about the Women's World Cup, you might see something like this return. You'll see a URL at the top. It's an ESPN.com URL, so it's an ESPN site about the Women's World Cup. A few down from there, which I failed to highlight, there's a description. It says follow all the latest FIFA Women's World Cup football news, etc. So there's a description of the URL. A few down from there, it says language EN, so you know it's English language, but again, we support over 30. It's a web result. It's 4 hours old. And there's something here called extra snippets. And this is something that we provide to a lot of AI partners. These are up to 5, if we can find them, good text summaries of the content on that page. So a lot of AI partners love that extra content because they train their models on them, or they might show that at inference time as part of the response to the user. So these are the extra snippets. And so you would take all this stuff and it would go into something that looks like this, right? This resembles kind of like a standard search engine results page, but you can very much see something like a chatbot interface where the chatbot is answering questions about the Women's World Cup. You can see for that specific entry, there are things that we've directly taken from the API on the previous page. So obviously the URL, the ESPN URL, the age, right, 4 hours ago, and then that description from earlier, the follow all the latest FIFA women's news, that's also from the API description earlier. So again, a very simplified example, but hopefully it gives you some idea of kind of the cool experiences that you might be able to build using a search API and creating kind of real-time experiences for your users. Yeah, we have a bunch of plans for the API and for a lot of different use cases. So you may be more on the traditional search side, or you may be on the AI side. And so we have a lot of plans kind of spanning the range of that, accommodating different volume needs as well. And so please, check out brave.com/API. And then also, if you're interested in what we're doing at Brave broadly, more than the search API, more than Brave Search, always feel free to check out brave.com. I think I'm just at time now. And so I think that's it from me. Thank you so much.